All right, almost there. Uncheck show tools, run for the improvement. Got you, right? Okay. All right, so yeah, you can, yeah, this one, something like this. So this is my advice. So if you find this weird looking derivative, you can say most of the time that's not reservoir characteristic, that's Weilbohr or Neil-Weilbohr phenomena, right? So I'm not going to honor that. I'm not going to be focused on that too much. That will waste my time because at the end of the day, what really matters is the reservoir characteristic, the permeability, something like that, right? Yeah. And that's why if you have multi-phase follow challenge like phase redistribution, using limited entry model also doesn't really helpful because the the period of hemispherical or spherical flow will be masked by the phase redistribution. Okay, so yeah, what really matters is that you put the permeability line. In my case, I use it around here, but I'm going to recheck it again, and I use closed reservoir boundary or constant pressure boundary to follow this downward trend. So I'm going to use vertical and constant P. All right, so I have two. And lastly, I'm going to create new, and I'm going to know the section of the derivative in which I assume, in which or on which I put my permeability line. What is the location at the semi-log plot for the same period? So I'm going to uncheck the show model and I will use single line. Yet in that way, in that location, I assume that will be the reference for my permeability. So if I zoom in, you see my straight line. Okay, and we'll check at the semi-log plot there. So the horizontal straight line, I put it here, at which or from which I will derive my permeability. The same time, in semi-log plot, that happens in this section. So if you want to argue or if you want to think using semi-log plot from which section we want to calculate the permeability, then I will say this is quite reasonable. All right, you take the permeability from this section, it's quite makes sense. It's straight line, it's clearly straight line, and yeah, and it's quite consistent. So I think it's quite makes sense if you take your permeability from that section, and you can also results in plot. This is the results in plot from semi-log plot analysis, and the semi-log gives you permeability of 9, and the log-log plot gives you permeability of 7.9. They are very close. All right, so perfecto. I think I'm going to stop here. Facing multi-phase flow issue, phase redistribution issue, it's not easy, but I think it's a good example. But of course, this is not the end. This is not the conclusion. Yeah, practically you need to discuss with your peers. You need to, yeah, try another model. something like that. But as far as this video is concerned, I think we can stop here and let us rethink again, and you can just, yeah, maybe we get insights from other sources. So I'm going to call it semi-lock check. All right, so that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching, and see you again in the next Eng-Man videos. Thank you.